Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is the database design concepts, and the same chapter, that is chapter number 19, that is the distributed databases. In the last class we have discussed about the distributed, or we have started with chapter number 19, that is a distributed database, that is how to use a distributed database, or what are the various advantages of distributed database, or what is distributed database, that is using the distributed environment, that is a distributed databases. So in the last class we have discussed about the chapter number 19, or we have started with chapter number 19. So let's start with the previous class session, then move to today's topic, that is how to maintain the database system, or how to maintain the distributed databases in the computer system. So chapter number 19 is the database or distributed databases, that is whenever we are going to convert, whenever we are going to take the same database or the same relation or the same, we can say, the table is distributed among the various databases. So same copy will be available at more than one place, that is a distributed database. So unlike parallel systems in which processes are tightly coupled and constitute a single database system, a distributed database system consists of loosely coupled sites that shares no physical connection. That is, they are distributed among each other, they are loosely coupled sites, there is no physical relation with each other, physical components are not attached with each other. Furthermore, the database systems that run on each site may have a substantial degree of mutual independence. That is, they are mutually independent with each other, they are not dependent on each other. But whenever we want a copy, for example in case of data theft or data loss, we can take the copy of the table, we can take the copy of the relation by using the concept of distributed databases. So each site may participate in the execution of transactions that access data to one site or several sites. The main difference between the centralized and the distributed system is that in a centralized, all the data resides on a single location, while in the distributed system, the data resides in the several locations. So in the centralized, every data is available at the one site, at the one location, while in the distributed system, the data resides in several locations, several directions. This distribution of data is the cause of many difficulties in transaction processing and query processing. Uh, then we also talked about the homogeneous and heterogeneous. Homogeneous means the similar elements are grouped together within the different types, that is a homogeneous database. That is, every site or all the sites have identical database management system software, are aware of one another, and agree to cooperate in processing users' request. That is a homogeneous distributed database system. In such a system, local sites surrender a portion of their autonomy in terms of their right to change schemas or database schemas available. So in a distributed database system, every site have identical database management system software and are aware of one another. In case of a heterogeneous distributed database system, different sites may use different schema. That is, different sites have a different schema that is available and different database management system software. The sites may not be aware of one another. That is, the different sites are not aware of each other, what is going on the current activity, and they may not provide only limited access for cooperation in the transaction processing. That is, different sites have a different schema, different options that are used for making the distributed system. That is a heterogeneous distributed database. And the homogeneous means everything is same, the schema is same, the site is same, everything is same. That is a homogeneous distributed database. In this chapter we concentrate on the homogeneous distributed databases, that is how to use the similar database that have or how when the different sites have different schema and when the different sites have same schema and the same structure. Then we also talked about the distributed data storage, that is what is distributed data storage, or what is the main advantage of storing the data in a distributed environment. Why we are storing the data in a same data will be stored in the multiple environment in the distributed environment, that is the distributed data storage. So this is, there are two approaches for storing the database in the distributed database. First is the replication, then fragmentation. Replication means same duplicate copies will be created, that is several identical replicas of a relation, and store each replica at a different site. The alternative to the replica is to store only one copy of relation R, that is a replication. That means several replication copies are formed and store each replica at a different site. So for example, if there are 5 sites, so each replication, we can say the database will be maintained at different levels, at different relation. That is a replica means a duplicate copies. Then next is the fragmentation, that is the same task or the same, we can say the relation is fragmented, or the one big table is fragmented into multiple parts, that is the fragmentation of the database. That is the fragmentation means distributed among various parts. The system partitions the relation into several fragments and store each fragment at a different site. That is, a relation is divided into various parts, and each part is stored at the different sites in the locality or in the site. This is the data replication, that is the data is stored at the different sites or in every site in the system, that is the replication. So there are a number of advantages and disadvantages to replication. There are numerous advantages, there are numerous disadvantages to the replication. Now what are the advantages? First one is availability. So if one of the sites containing relation R fails, so this is the one of the advantage, that is if any site fails, so the data will be recovered from another site, that is availability, that is the data is available at all the times. Then increased parallelism, that is the more and more data will be available in a parallel, where the majority of the access to the relation in using in reading the data, reading the relation. Then increased overhead on the update, that is a limitation, that is there will be a more overhead, more cost will be required on every update. So if there is any update, so the all the sites have to be updated the same information, the same data that is updated. So it costs around too much, that is it increases the overhead. So whenever there is a update, so that amount of overhead will be increased. In general, replication enhances the performance of read operations and increases the availability of data to read-only transactions. Then data fragmentation, that is the same data will be divided into multiple parts, into multiple fragments, and these fragments contain sufficient information to allow reconstruction of the original relation R. And there are two different schemas for fragmenting a relation. One is a horizontal fragmentation, one is a vertical fragmentation. Horizontal fragmentation splits the relation by assigning each tuple of R to one or more segments. And vertical relation splits the relation by decomposing the schema of the relation R. So in the horizontal fragmentation, each relation R is partitioned into number of subsets. There are multiple subsets that is available for the horizontal fragmentation. An account relation can be divided into two or into several different fragments, each of which consists of the tuples of accounts belonging to a particular branch. This is the one of the example, that is a horizontal fragmentation. In general, our horizontal fragment can be divided as a selection on the global relation R. That is, we can use the predicate to construct the fragment Ri. This is the vertical fragmentation, that involves the definition of various subsets of the attribute that is available. That is, for example, R is a relation R. Then next is the transparency, that is what are the various transparencies that is available in the database systems. So the use of a distributed database system should not be required to know the data is physically located, nor the data can be accessed at a specified location. That is, the data will be, or the one of the characteristics of the database will be data transparency, that takes several forms that is available. One is the fragmentation transparency. Users are not required to know how a relation has been fragmented. That is, and the fragmentation is not visible to each and every user. So that is a fragmentation transparency. Then replication transparency, that is a duplication of the various sites. The same data will be available at multiple sites. That replication will also not be available, not be visible to each and every user. Then location transparency, that is a location is not we can say the transparent to each and every user. Then next is the distributed systems, or we can say the distributed transaction. That is the today's topic. So let's start with the today's topic. So we have covered with the distributed database till now in the distributed database chapter. Now this is the distributed transaction, that is how to distribute the transactions among various parts, not the whole database, not the relation, but now it's the time to distribute the transactions in the distributed environment in the computer system. So access to the various data item in a distributed system is usually accomplished through transactions. That is, whatever the data item that is available in the distributed system, that is available through the transactions that is used, which must preserve the acid property, that is the atomicity, consistency, isolation, and the durability. There are two types of relation that is available. One is the local transactions, one is a global transaction. In a local transactions, that access and update data in only one local database. That is, there is only one local database. The transactions will be accessed and updated in the local database system. And the global transactions are those that access and update data in several local databases. That is, local means only one database. Any access, any updation will be available in the local transactions, and the global means the same data will be available in the global transactions. Local to each and every one, that is local to the various bodies, or that is local transaction, that is that can access and update data in only one local database. That is only one local database can access or update the information that is available in the local transactions. And the global transactions are those that access and update data in the several local database. That is, they are used to access the various data, or they are used to update the various information in multiple databases. And ensuring the asset properties of the database of the local transaction can be done in chapter 14, 15 and 16. That is the atomicity, durability, consistency and the isolation. However, for general or global transaction, this task is much more complicated since several sites may be partitioning in execution. The failure of one of the sites or the failure of a communication link connecting these sites may result in enormous computation. So whenever there is failure in any site or failure of a communication link that connects these sites may result in enormous computation. We can say the can result in the enormous computation that is available in the communication site. In this section, we study the system structure of a distributed database and its possible failure modes. In section 19.4, we study the protocol for ensuring atomic commit of global transactions. That is, there will be atomic commit of global transaction that is available in the global sites. In section 19.4, we study the protocol for ensuring atomic commit of global transactions, and we study the protocol for the concurrency control in the distributed system. That is a distributed system or distributed transactions. Then next is the system structure. That is how to use the system structure. What is the main advantage of using the system structure? So each site has its own local transaction manager. That is, every site has its own local transaction manager whose function is to ensure the asset properties of those transactions that executes at that site. So it provides the execution of the site. It provides the local execution whose function is to ensure the asset property. That is atomicity, consistency, isolation and the durability that they can execute at that site. The various transaction managers cooperate to execute the global transaction. So there are multiple managers that is used to cooperate with the global transaction that is available. And to understand how a manager can be implemented, they can provide each site that there are two subsystems that is available. First is the transaction manager that manages the execution of those transactions. There will be a transaction manager who manages each and everything, the execution of those transactions that access data stored in the local disk. So whenever there will be accessing of data that is available, so there is a transaction manager who manages the execution of each and every transaction that is available in the local site. Note that each such transaction may be either a local transaction or a part of the global transaction. So transaction manager may handle both the transaction, that may be a local transaction, that may be a global transaction. Then there are again next subsystem that is available is the transaction coordinator that coordinates the execution of various transactions that is initiated at that site. Coordinate execution means they coordinate means they cooperate with the various transactions that is available at various sites, and there are both the transactions are used, that is the local transaction as well as the global transaction. The structure of a transaction manager is similar in many aspects to the structure of a centralized system. So whatever the structure of a transaction manager, that is very much similar in many aspects to the structure of a centralized system. Each transaction manager is responsible for. So what are the various responsibility of transaction manager? First of all, maintaining a log for the recovery purpose. If there is any recovery purpose, to maintain a log side by side so that in case of failure, when the failure removes, the data recovers, so there will be maintaining a log, that is after that log we have to maintain the local database. This is computer 1, this is computer and there is a multiple computer that is used. This is a TC1, there is a transaction coordinator 1, then there will be a TM1, that is a transaction TM1. So there are multiple transactions, there are multiple transaction managers, there are multiple transaction coordinators. This is a system architecture. Then participating in the appropriate concurrency control is also helpful in increasing the coherent or concurrent execution of the transaction executing at that site. So whatever the transaction that is available, they execute at the site that is available for the transaction. The transaction coordinate or coordinator subsystem is not needed in the centralized environment since a transaction accesses data at only a single site. That is, the data is available only a single site. That is not transaction coordinator subsystem is not required in the centralized system, centralized environment. A transaction coordinator, as a name implies, is responsible for coordinating the execution. So what are the various responsibilities of the coordinator? First of all, it it is responsible for starting as well as the ending of the execution of the X transaction. That is, what is the starting phase of the transaction, what is the ending phase of the transaction that is executed, or that is done by the transaction coordinator. Then breaking the transaction into number of sub transactions, that is breaking the number into various transactions or sub transactions, so that they are available at the different sites, they are available at the different places. Then next is the coordinated termination of the transactions, which may result in the transaction being committed at all sites or aborted at all sites. That is, coordinate the termination of the transaction, that is how to terminate the various databases and how to maintain the termination and how to provide the result from the transaction that is being committed at the all the sites. Next, system failure mode, that is what are the various modes in which the system fails. So a distributed system may suffer from same type of failure that a centralized system does. So whatever the distributed system that may suffer from the same type of failure that a centralized system does. For example, software errors, hardware errors, or the disk crashes. That is a distributed system that suffer from the various failures. There are, however, additional types of failure that is also available that needs to deal with a distributed environment. So what are the various basic failure sites or failure types? That is the failure of a site, loss of messages, failure of a communication link, network partition. These are the various failure that is available in the site, that is available in the distributed environment. So loss or corruption of the messages is always a possibility in the distributed system. The system uses transition or transmission control protocol such as TCP/IP to handle such errors. There will be a protocol that is available, that is a TCP/IP protocol to handle such error, that is a transmission control protocol, internet protocol. And whatever the information that is provided about such protocol may be found in the standard textbooks on networking that is available. And the system is partitioned if it can be split into two or more subsystems known as the partitions that lack any connection between them. Note that under this definition, a partition may consist of a single node. So whatever the single node that is available, they may be followed with a single transaction. Then next is the 19.4 is the commit protocol, that is how to commit the protocol. What are the commit protocol that is used in the transaction? Next is the commit protocol, that is what are the various commit protocol that is used in the database system, that is used in the database distributed database management system. So if we are to ensure the atomicity, so if we are to ensure the atomicity, that atomicity takes place, all the sites in which a transaction T executed must agree on the final outcome of the execution. That is, if I want that atomicity will be maintained, so every transaction, all the sites in which a transaction T is executed must agree on the final outcome of the execution. T must either commit at all the sites or it must abort at all the sites. So T is either commit at all the sites, it must abort at all the sites. To ensure the property or to ensure this atomicity property, the transaction coordinator of T must execute a commit protocol. So to ensure the property of this commit protocol, the transaction coordinator of the T must execute a commit protocol, that is how to commit the protocol, what are the various rules to commit the protocol. Among the simplest and the most widely used commit protocols is the two-phase commit protocol. So there is a protocol that is available, that is the most commonly used commit protocol, that is a two-phase commit protocol, that is a 2PC. An alternative to the three-phase PC, that is an alternative to the three-phase commit protocol, is also used to avoid certain disadvantages of the 2PC protocol. So there's a new protocol that is used, that is the third phase or three-phase commit protocol, that is more better than the two-phase commit protocol. But the disadvantage is that it adds the complexities, that the complexity is added, and there will be a more cost, that is the overhead is also increased in case of the three-phase commit protocol as compared to the two-phase commit protocol. The first is a two-phase commit protocol that is used, that operates during the normal operation. So whatever the normal operation that is used, so the two-phase commit protocol is used for the normal functionality. So consider a transaction T that is initiated at the site S1 where the transaction coordinator is CI. So there is a transaction coordinator that is a CI and transaction name is T that initiated at the site, that is a SI. The commit protocol is used so when T completes its execution, that is when all the sites at which T has executed inform CI that T has completed, CI starts the 2PC protocol. Then it's the responsibility of the CI to start the 2PC protocol, that is a two-phase commit protocol. Now what is the phase 1? That is the CI add the records, prepare T to the log. So CI, that is we can say the commit protocol or coordinator, adds the record prepare T to the log that is available and forces the log onto the stable storage. It then sends a prepare T message to all the sites at which the T executed. Then phase 2 means CI receives the response to the prepare T message that is available from all the sites, and when a pre-specified interval of the time has elapsed since the prepare T message was sent out, CI determines whether the transaction can be aborted or committed or aborted. That is phase 2 contains various protocol that is used, that the transaction coordinator is used to commit the protocol to access the protocol. Transaction T can be committed if CI receives a ready T message from all the participating sites. Otherwise, the transaction T must be aborted. So this is the transaction that is executed for the aborted transaction for the unnecessary transactions. And a site at which the T executed can unconditionally abort T at any time before it sends a message ready T to the coordinator. That is a site at which the T executes a transaction that is unconditionally, that is at any time it aborts the transaction T at any time before it sends the message ready to the coordinator. And once the message is sent, the transaction is said to be in the ready state at that site. The ready T message is in fact by promise by the site to follow the coordinator order to the commit T or to the abort T. To make such promise, the needed information must be or first be stored in the stable storage, or must be stored in the table storage. Otherwise, if the site crashes after sending ready T, it may be unable to make a good on its promise. There will be a abort function that is also covered, that is unconditionally occur, that is abort T. The next is the handling of the failure, that is how to handle the failures. The two-phase commit protocol, that is a 2PC protocol, respond in many ways to the various types of failure. There are multiple types of failure that is available. The first one is the failure of a participating site. That is, whatever the failure that is available on a participating site, that is available, or failure of a participating sites. So if the coordinator CI detects that a site has failed, it takes these actions. So if the site fails before responding with the ready T message to the CI, the coordinator assumes that it responds with an abort message. So but whenever there will be a failure of a participating site that is available, it takes the messages, it takes the actions and aborts the transaction that is available with the ready T message to the CI. The coordinator assumes that it is responded with the abort T message. And if the site fails after the coordinator has received the ready T message from the site, the coordinator executes the rest of the commit protocol in the normal fashion that is available in the commit protocol, ignoring the failure of a sites. And when the participating site SK recovers from a failure, it must examine its log activity to determine the fate of those transactions that were in the midst of the execution. That is, a log will also maintain to fate the execution method of the database system. Let T be one transaction. We consider the possible cases. There are multiple possible cases that is used to follow the transaction. The log must maintain a commit protocol or commit T record. In this case, the site executes the redo transaction. The log contains an abort T record. In this case, the site executes the undo. So in the case of commit, there will be a redo operation. In case of abort, there will be a undo operation. And log also maintains a ready T transaction to abort the transaction. Then next is the failure of the coordinator. That is, if the coordinator fails, what is the main target of the failure of the coordinator? So if the coordinator fail in the midst of the execution, so if the coordinator fail in the middle of the execution of the commit protocol for transaction T, then the participating sites must decide the fate of the T. We shall see in the certain cases the participating sites cannot decide whether to commit or abort the protocol in case of a failure of a transaction. That is one of the major drawbacks, that is whenever the failure fails, it is the responsibility of the various transactions, that is what to do, how to do, whether to commit the protocol, whether to abort the protocol. And therefore these sites must wait for the recovery of the failed coordinator, so that the new coordinator will come, then only then they are executing the transaction, they are executing the sites, either follow the commit protocol, either follow the abort protocol or abort function. So if an active site contains a commit protocol records in its log, then T must be committed. And if an active site contains an abort protocol or abort T function, then the T must be aborted. And if some active site does not contain a ready T record in its log, then the failed transaction or the failed coordinator CI cannot have decided to commit T, because a site that does not have a ready T records in its log cannot have a ready T message to the CI. So this does not have a C message to the CI that is available in the transaction function. And if none of the preceding cases holds, then all the active sites must have a ready T records in their logs, but no additional control records. Since the coordinator has failed, it is impossible to determine whether a decision has been made, and if one has, what decision is, until the coordinator recovers. Therefore, the active sites must wait for the CI to recover. Since the fate of T remains in doubt, T may continue to hold the system resources. That the T must continue to hold the resources that is available, and if blocking is used, the T must block the various sites, that is a blocking mechanism, because T is blocked pending the recovery of the site CI. And this situation is known as a blocking problem. Now next is the network partition. That is whenever there will be a network partition, there is a partitioning of the network. So what are the two possibilities that exist? The first one is the coordinator and all its participants remain in one position. So whatever the coordinator, whatever the participant that is available, they remain in one partition. That is every coordinator, every participant is available in only one partition. In this case, the failure has no impact on the or no effect on the commit protocol. So whenever everything is available on the one partition, so there is no effect, or there is no effect of the commit protocol. There is no effect of the commit protocol that is available in the transaction methods. The coordinator and the participants belong to several partitions. From the viewpoint of this partition, it appears that the sites in other partition have failed. And there are two major disadvantages of 2PC protocol is that coordinator failure may result in the blocking. So if there is any a coordinator fail, as I said, there will be a result in the blocking. Then next is the recovery and the concurrency control, that is how to recover and how to provide the concurrency control. And to avoid the limitations of the two-phase commit protocol, the next protocol will be introduced, that is known as the three-phase commit protocol. So this is an extension of the two-phase commit protocol that avoids the blocking problem, due to the transaction coordinator fails under certain assumptions. That is, there are some assumptions in which the transaction, if the transaction coordinator fails, so there will be no lacking of data, there is no blocking of the data. In particular, it is assumed that no network partitioning occurs and not more than k sites fails, where k is some predetermined number. Under these assumptions, the protocol avoids blocking by introducing an extra third phase where multiple sites are involved in the decision to commit. Instead of directly noting the commit decision in the persistent storage, the coordinator first must ensure that at least k other sites it is intending to commit the transaction. That is, k sites will be available to commit the transactions. While the 3PC protocol has a desirable property of not blocking unless k sites fail, it has a drawback that a partitioning of the network may appear to be same as more and more than k sites failing, which leads to the blocking. So whatever the blocking that is available, that data will be available in that site. And because of its overhead, the 3PC protocol is not widely used. Then next is what are the alternative models, what are the alternative methods of the transaction processing. There are multiple transaction or multiple method that is used, that is the persistent messages, and there are various application that is used, and how to implement that by using the sending side protocol that is used, then receiving side protocol, that at the receiving end there is a protocol that is used. The next is the concurrency controls in the distributed database. That is, what is the concurrency control in the distributed database, or how to maintain the concurrency control in the distributed database. Concurrency controls in the distributed databases, that is how to maintain the concurrency control among the distributed databases, or what are the various rules and regulations to follow to maintain the concurrency control in the distributed databases. So we show here some of the concurrency control scheme that is discussed in chapter 15, that is what are the various concurrency control. Now how to use a concurrency control in the distributed databases that can be modified so that they can be used in a distributed environment. We assume that each site participates in the execution of a commit protocol to ensure global transaction atomicity. So each site that is available in the commit protocol to ensure the global transaction atomicity that is available in the concurrency control. And the protocol we describe in this section requires update to be done on all the replicas that is available of a data item. If any site that pertaining or that containing a replica of a data item has been failed. So if any site that fails, update of or updation of the data item or updation to the data item cannot be processed. So if any sites fails, then the updation that is available in the replica of a data item has not been or cannot be processed. In section 19.6, that is the next section, we assume or we describe multiple protocol that is available or that can continue the transaction processing even if the some sites or links have been failed. That is how to maintain the transaction processing if some sites have failed or some sites have addendum. Then next is the locking protocol. That is what are the various locking protocol, what is the locking protocol, what are the various protocol that is available in the locking. So various locking protocol that describes in chapter number 15 can be used in a distributed environment. The only change that needs to be incorporated is in the way the lock manager deals with the replicated data. That is the only change that is incorporated is the way that is how to manage the lock manager or how to use the lock manager that is dealt with the replicated data. We present several possible schemes that are applicable to an environment where data can be replicated in several sites. As in chapter 15, we shall assume the existence of the shared and exclusive lock mode. So what is the shared exclusive lock, what are the exclusive lock mode that is available in the locking protocol. So this is a locking protocol. First approach that is used is single lock manager protocol. That is a single lock is available. That is single lock manager protocol. That is only a single lock manager or manager protocol. The system maintains a single lock manager that resides in the single chosen site. So there is only one site and there will be only single lock manager that resides in the single chosen site. Say SI. All the lock and the unlock requests are made at the site SI. So whatever the request that is made at the SI. When a transaction needs to lock a data item that is available, it sends a lock request to SI. So whatever the transaction that is needs to be locked at data site that is available at the SI. The lock manager determines whether the lock can be granted immediately or not. So whatever the lock manager that is determined, that can be granted immediately or not. If the lock can be granted, the lock manager sends a message to that effect to the site at which the lock request was initiated. And in case of a write, all the sites where the replica of the data item resides must involved in the writing. So in case of a writing a part, all the sites that is available where a replica of a data item that resides must be involved in the writing. So whatever the write operation that is used, whatever the site that is used where the replica of a data item resides must be involved in the writing. The scheme has three as the advantages. So what's the advantage of this single lock manager approach? First is a simple implementation. That is implementation, or we can say the implementing the single lock manager is very easy task. That is a simple implementation. This scheme requires two messages for handling long request or lock request and one message for handling unlock request. Then simple deadlock handling. Next one is, so since all the lock and unlock requests are made at the one side and deadlock handling mechanism is available that can be applied in the direct manner. Then next is the bottleneck. That is the site SI become a bottleneck since all the requests must be processed there. That is the bottleneck. Then vulnerability, that is if the SI or site SI fails, then the concurrency control is lost. That is the vulnerability. So if any site SI or if any site that is available, if the site that is available fails, then the concurrency control is lost. So these are the various advantages, these are the various disadvantages of the bottleneck or the first approach that is used. So what are the advantages? Simple implementation. Next advantage, simple deadlock handling. Disadvantage, bottleneck. Disadvantage, vulnerability. The next is the distributed lock manager. So in the same way, there is a distributed lock manager also in which the lock manages in the distributed environment. So a compromise between the advantages and disadvantages can be achieved through the distributed lock manager approach. So there is a compromise that is balanced between the advantages and the disadvantages. What type of advantage, what type of disadvantage is available, that can be achieved through the distributed lock manager approach, in which the lock manager function is distributed over several sites. So in which the lock manager approaches is available or followed over the different sites. Each site maintains a local lock manager whose function is to administer the lock and unlock requests for those data items that are stored in that data site. And whenever the transaction or when a transaction wishes to lock a data item Q that is not replicated, that is not duplicate and resides at the site SI, a message is sent to the lock manager at the SI. that requests the log manager. So once it determines the log request can be granted, the log manager sends a message back to the initiator indicating that it has granted the log request. So whatever the log request that is available, that is distributed among the various manager, that is a distributed log manager. We discuss several alternative ways of dealing with replication of the data item that is available in the section 19.5.3 to 6. Then the distributed log manager scheme has advantage of simple implementation and reduces the degree to which the coordinator is a bottleneck. So whatever the degree that is available in the bottleneck, whatever the approach that is available in the bottleneck, that reduces the degree to which a coordinator is a bottleneck. It has a reasonably low overhead, requiring 2 message transfer for handling lock request that is available, 1 message for handling the unlock request. However, deadlock handling is more complex. That is, whenever we have to handle the deadlock, that is more complex since the lock and the unlock request are no longer made at one side. So there is no longer request that is available at the one side that is used in the bottleneck, that is used in the deadlock handling. The deadlock handling algorithm is also available to modify the version of a single site algorithm. Now next is a primary copy. So what is a primary copy? When a system uses data replication. So when a system uses data replication, data duplication, we can choose one of the replicas as the primary copy. So whenever there are multiple copies of the same database, so one of the copy that is available, one of the data that is available, that is considered as a primary copy. For each data item Q, the primary copy of the Q must reside in precisely one site, which we call the primary site of Q. And when the transaction needs to lock a data item Q, it requests a lock at the primary site of Q. So whenever a transaction that needs to lock a data item Q, it requests the primary site. So first of all, it requests the primary site, that is a unlock the data, unlock the item that is available to unlock the various variables. The response to the request is delayed until it can be granted. The primary copy enables concurrency control for replicated data to be handled like that of the unreplicated data. So whatever the replicated data that is available, that is duplicate data, that can be handled much like the unreplicated data. The similarity, or whatever the similarity between the replicated and the unreplicated data, that ensures that for the simple implementation this similarity is very essential. However, if the primary site of Q fails, Q is inaccessible. So whatever the site that is available, that is inaccessible, even when the other sites containing a replica may be accessible. That is a primary copy. The next is the maturity protocol that works this way. So if the data item Q is replicated in n different sites, so if there are a data item that is available that is replicated in the n different sites, then a log manager request or message must be sent to more than one half of the n site in which the queue is stored. So whatever the site that is available in the database management. Each log manager determines whether the log can be granted immediately or not. As before, the response is delayed until the request can be granted. So if the response is delayed, until the request can be granted, on which the queue will be maintained. We assume for now that writes are performed that on all the replicas requiring all sites that can be available on the database items. And protocol also deals with the replicated data in a decentralized manner. So whatever the protocol that is available in a decentralized manner, thus avoiding the drawbacks of the central control. However, it suffers from these disadvantages. So what are the various disadvantages that is available? So first disadvantage is that implementation. So the implementation is very critical issue in the database management system, that is the implementation. So the majority protocol is more complicated to implement than our previous scheme. So whatever the protocol that is available, that is more complicated than the previous scheme. Then next is the deadlock handling. So in addition to the problem of global deadlocks due to the use of a distributed lock manager approach, it is possible for a deadlock to occur even if one item will be locked. As an example, if with 4 sites full replication, TI will be locked and the queue will be maintained, that is a deadlock handling. Next protocol is the biased protocol, that is an approach for the handling the replication. So if there are more replicated data that is available, and how to handle that replication, that is handled by the protocol that is known as the biased protocol. And the difference between from the majority protocol is that requests for shared logs are given more favorable treatment than requests for the exclusive log. That is a biased protocol. So there are 2 types of logs that is available. One is the shared log, one is the An exclusive lock. In the shared lock, the lock will be available or it will be shared among the various users among the various content. And the exclusive means there is only one lock that is available that is used to lock the specified item that is available in the database system. So when a transaction needs to lock the data item Q, it simply requests a lock on the Q from the lock manager at one side that contains a replica of Q. When a transaction needs to lock data item Q, it requests a lock on the Q from the lock manager at all the sites that contains a replica of Q, that is exclusive lock. As before, the response to the request is delayed until it can be granted. The bias system has advantages of imposing less overhead on the read operations. Next up, protocol is quorum census protocol, that is a generalization of the majority protocol. That is whatever the majority or whatever the protocol that is used, that is a quorum consensus protocol that assigns each site a non-negative weight. And to execute a read operation, enough replicas must be logged then that their total weight is at least R. Now next is timestamping. That is what is timestamping, how to use a timestamping. That is one of the important critical issue that is available in the timestamping. So the main idea behind the timestamping section in section 15.4 is that in each transaction is given a unique timestamp, that is a unique ID is given to each and every transaction, so that the data will maintain or the system used in deciding the unique timestamp that the system using in deciding the serialization order, so that the transaction will be available in the serialized order. One transaction will be executed after the another. And there are various protocols that operate directly to the non-replicated environment. There are two primary methods for generating the unique timestamp. One is the centralized method, one is the distributed method. So there are two primary methods that is used to, we can say the supply that is used to provide the timestamping, unique timestamping that is available. There are two approaches, one is centralized, one is the distributed. And in the centralized scheme, a single site distributes the timestamping. There is a single site that distributes the timestamping, and the site may use a logical counter on its own local clock for the purpose. Then in the distributed scheme, each site generates a unique local stamp by using either a logical counter or the local clock. So whatever the logical counter, whatever the logical clock that is available, local clock that is available in the distributed scheme. We obtain the unique global timestamp by concatenating the unique local timestamp with the site identifier, which also must be unique. So whatever the timestamp is available, that is available with the site identifier. And the order of concatenation is very important. We can use the site identifier in the least significant position to ensure that global timestamp generated in one site are not greater than the other site. These are the various timestamping protocols. That is the generation of unique timestamp. This is a local unique timestamp, then site identifier, then this is the global unique identifier. The next is the replication with weak degrees of consistency. That is, if any duplication is maintained with a weak degree of consistency, that is how to maintain the replication, how to maintain the relation with the weak degree of the consistency. So many commercial sites that is available, many commercial data that is available, many commercial databases today supports the application which can take care of the several forms. So there are multiple several forms that is used with the various application methods. With master-slave replication. So if there is a master-slave replication, the database allows update at the primary site. The database that is allowed, that is available at the primary site, and automatically propagate the update to replica at other sites. The transaction may need or read the replicas at other site, but are not permitted to update them. An important issue in feature of such replication is that transactions do not obtain logs at the remote site. So whatever the transaction that is available, they are not available the logs on the different sites. So they do not obtain the logs at the certain sites. To ensure that transactions running at the replica site see a consistent, that is available view of the database, the replica should reflect a transaction consistent snapshot of the data at the primary level. So whatever the primary level that is available, they are obtaining the database system, they are obtaining the transaction consistent snapshot of the data. That is, the replica should reflect all the updates of the transaction up to some transaction in the serialization order. So whatever the transaction, whatever the replica that is available in the serialization order, and should not reflect any update of later transaction in the serialization manner or order. and the database may be configured to propagate update immediately after they occur at the primary or they occur in the periodical manner. Then master slave replication is particularly useful for distributing the information. So master slave replication that is useful for distributing the information that is available, for example, from a central office to branch office of an organization. That is useful for we can say distributing the information from the central location to the branch location, from the branch location to the central location. Another use for this form of replication is in creating a copy of the database to run large queries. The query will be maintained in the Oracle database. The Oracle database system supports a create snapshot statement which can create a transaction consistent snapshot copy of the relation or set of the relation at a remote site. That is a create snapshot statement. Then with the multi-master replication that is used, also known as the update anywhere replication, updates are permitted at any replica of a data item. So the application will be provided, data will be provided with the various master database available that is used in the replication of the database systems. This model is the basic model to manage the replicas in distributed databases, and transactions update the local copy and the system updates other replication transparency. And one way to updating the replica is to apply immediate update with two-phase commit protocol. That is one way to updating the information, that is to apply the two-phase commit protocol that is used in the database management system. Many database system provides an alternative way of the updating, that is they are using the lazy propagation that is used with the content of the database available. So updates at the replica are translated into updates at the primary site, which are then propagated lazily to all the replicas. The next is the deadlock handling. That is how to handle the deadlock. What is the deadlock handling situation? That is use the deadlock prevention methods. So the deadlock prevention and the deadlock detection algorithm that is used in, or that is discussed in chapter number 5, can be used in, also be used in the distributed system. So whatever the algorithm that is we have covered in chapter number 15, that also be used in the deadlock handling, that also be used in the distributed databases. For example, we can use the tree protocol by defining a global tree among the system data items. Similarly, the time step ordering approach could be directly applied to a distributed environment. Deadlock prevention may result in unnecessary waiting and rollback. So whatever the content we are using, so whenever there will be deadlock prevention, that may result in unnecessary waiting and the rollback. Furthermore, certain deadlock prevention algorithm must be revised or must be required more sites to be involved in the execution of a transaction that would otherwise be the case. So whatever the case, whatever the transaction that is used, they must be used in the execution of a transaction that would otherwise be the case that is available for the deadlock prevention. So this is the local wait for the graph. This is T1, T2, T3, T5. So T1 is waiting for T5 and T2 is waiting for T3. This is a local wait graph or local wait distributed graph. And these are the various mechanisms that is used with the rollbacks. One is the fall cycle that exists. Then there will be deadlock that is available in the database system. Now next is the availability, that is the data is available in the distributed system, that is the availability, and what are the various approaches in the availability. So one of the goal in the distributed system or distributed data is high availability. So one of the goal that is available in the distributed system, that is a high availability, that the data is available from any site that is available, that any site that is used, that is a high availability. That is the database must function almost all the time. That is the database must function at all the time that is available. That is the information is available from the database from all the times. In particular, some failures are more likely in the large database system, large distributed system. A distributed database must continue functioning even when there are various types of failures. If there are multiple types of failure that is used, that must be available with various databases. The ability to continue functioning even during the failures is known as the robustness. So whatever the robustness, whatever the data that is available, that must be available in the robustness state. For a distributed system to be robust, it must detect the failures, reconfigure the system so that computation may continue. So if any distributed database system must be robust, it must detect the failures, again reconfiguring the systems so that the computation may compute or may continue and recover when a processor or a link is repaired. So whenever the repair is processed, whenever there will be detection of the failure, that must reconfigure the system so that the computation may continue the various repairs. The different types of failures are handled in the different ways. For example, message loss is handled by the retransmission. So whatever the message load that is available, that is handled by the retransmission. Repeated retransmission of a message across a link without receipt of acknowledgement is usually a symptom of link failure. So whatever the link failure that is available with the symptom of a link failure. The network usually attempts to find an alternative route for the message, and failure to find such a route is usually a symptom of network partitioning. So whatever the network partitioning that is used, that is symptom of the network partitioning. It is generally not possible to differentiate clearly between the site failure and the network partition. The system can usually detect that a failure has occurred, but it will not be able to identify the type of failure. For example, suppose that the site S1 is not able to communicate with site S2. It could be that S1 has failed. So there will be possibility to get the error that the data will be available. So there is a high availability of the database in the distributed system. Suppose that the site has recovered that failure has occurred. It must then initiate a procedure that will allow the system to reconfigure and continue with the normal mode of operation. So whatever the normal form mode that is available with the mode of the operation. And if the transactions are active at a failed inaccessible site at the time of the failure, these transactions should be aborted. So whatever the transaction that is available, that must be aborted in the various transactions. It is desirable to abort such transactions promptly since they hold locks on the data that is available at the various sites. And if the replicated data is stored at the failed inaccessible site, the catalog should be updated so that the query did not or do not reference the copy at the failed site. And if the failed site is at a central server for some subsystem, an election must be determined the new server. So in particular, what are the situations to ensure the consistency? Two or more central servers are elected in a distinct partition. That is, two or more servers are used as a distinct partition so that they are partitioned among each other. More than one partition updates a replicated data item. These are the various approaches that is used in the database or distributed database system so that the high availability will be maintained. So these various approaches I am going to cover in the next class, that is in tomorrow's class. So that's all for today's session. If there is any doubts, any confusions, you can ask the doubts from me. And if there is any other query that is related to the module, unrelated to the module, you can ask the doubts from me. Alright. So thanks a lot everyone. Bye bye everyone.